So to understand uniform circular motion, let us have an example. Here we have a moon, and let us assume that this moon is moving with uniform speed. Now, if I apply force on this moon, obviously it will start moving and it will cover a certain amount of path. But we want to make sure that this path is a rectangular path. So how many times do we have to apply force? Let us see. This is the first one. Here it goes the second time. Here it goes the third time. And finally, it is the fourth time. That means this object changes its direction 4 times, right? So the shape is a rectangular shape. But we should understand over here that the speed is constant, but the velocity keeps on changing. Now, how does this happen? We know that velocity is a vector quantity, right? So if the direction changes, obviously velocity will also change. So keep this in mind that the speed is constant, but the velocity keeps on changing. Now here the path was a rectangular path. Now we need a hexagonal path. So how many times will the object have to change its direction? Let us see. 1, 2, 3, 4, 5 and 6 times. So the object changes its direction 6 times over here. Similarly, for the path to be octagonal path, it will have to change its direction 8 times. So here it changes the direction 8 times. So if we want this object to move in a circular path, how many times will this object have to change its direction? And the answer is infinite number of times, n number of times. So here the object changes its direction infinite number of times. So let's say we have Earth at the center. That means the satellites that actually move around the Earth, they move in a circular path, and this motion is called as circular motion, right? So in uniform circular motion, what happens is the direction of motion changes continuously with time. We know that the speed is constant, but the velocity keeps on changing. Why? Because the direction keeps on changing. So what is circular motion? Circular motion is nothing but motion along the circumference of the circle. So what is uniform circular motion? Just add the word with constant speed and you get the definition of uniform circular motion. So when an object moves in a circular path with uniform speed, its motion is called as uniform circular motion. Or we can also say that motion of an object along the circumference of the circle. Remember, motion of an object along the circumference of the circle with constant speed is called as uniform circular motion. So now we know what the definition of uniform circular motion is. Now let us understand one more thing. Now we know when any particular object moves in a circular path. Now this is a moon revolving around the Earth. Now this moon wants to go straight, but the gravitational force of the Earth pulls it towards itself. Thereby we can see a circular motion. That means at every point, this moon is changing its direction. Now, since the direction is changing, we know that the velocity is changing. But whenever velocity changes, that is called as acceleration. Remember? Because acceleration is nothing but change in velocity. That means uniform circular motion is also called as an accelerated motion. It is also called as an accelerated motion. Now let us derive a formula for speed in circular motion. We know that speed is equal to distance upon time, right? So the formula is distance upon time. But how much is the distance covered by this moon in one motion? That is nothing but the circumference of the circle. So instead of distance, we write circumference, and time remains time, or we can say time period. What is the formula for circumference? It is 2 pi r, right? And speed is denoted by v. So we have v is equal to 2 pi r, that is nothing but the circumference, upon time denoted by t. So this is the formula for speed in uniform circular motion, and the formula is v is equal to 2 pi r upon t.